Let us start with the first type of mean, that is arithmetic mean. What is it? We can define it as a set of observation, the sum which can be calculated by dividing the sum of observation by its number. It can be calculated from the distribution without frequency, and it is termed as simple arithmetic mean. And how we can calculate is, let us have this numerical, this formula which is there in the front of you. What does this formula talks about? It says that if the number of observations are there from x1 to xn, simply add these values and divide with the number of observation. So the formula comes up to be the summation of xi divided by n, where I stands from 1 to n. And what is n? N is the number of observations. Simple formula of a average that we do. Second type of arithmetic mean which we talked about was a weighted mean, where we are provided with the weightage of each observation. The formula is there in front of you, where W1, W2 stands for the weightage of x1 and x2 and so on. Simply we have to multiply the weightage with the values and divide with the sum of the weightage. If we consider the observations right from x1 to xn, and each will be provided with the weightage of w1 to wn, the formula gives you the weightage mean. It can be used in the case the relative importance of the each observations when it differ, or when like the rates, percentages, or the ratios are being averaged. The application is basically and specifically is in such cases of weightage mean. Although the arithmetic mean is not only the mean, there is also geometric and harmonic mean, two more concepts, and they are but they are not not commonly used. Therefore, if the term mean comes without specifying the word arithmetic, the geometric mean or harmonic mean is never been assumed. What we do is, in generally we represent the arithmetic mean with the x bar. See, if you are using the variable x, and if you have to represent the arithmetic mean, we represent it by the x bar. If the variable is represented by y, then the mean has to be y bar. It stands that this is an average of the all observations. Simple formula, sum of all, this is summation, sum of all the values divided by n number of observations, where it's I stands from 1 to n. Similarly, if it is y, sum of all the values of y divided by n, whatever the variable you are using, the bar has to be above it, and then it gives you the, it represents you the arithmetic mean. So that you have to be taken care that there are certain notations which are standard, which we're going to follow in our session also. When we calculate arithmetic mean for the ungrouped frequency distribution, we talked about frequency distribution of two types, grouped, ungrouped. In ungrouped, we have individual series. In grouped, we have two, discrete and continuous. So in individual series, when we have ungrouped data, simple formula, this will be applied. But when there will be a grouped frequency, there will be a frequency available with the values. Let us repeat once again. If there are only x values given like this, right? No repetition, need not to write frequency 111. Remember the case. So this type of data where frequency is not written over there because these values have appeared only once. So this is called ungrouped data, that is individual series. In this case of individual series, we will be applying simple formula and we will find out the arithmetic mean. But in case when the grouped data is given, definitely frequency will be there because repetition occurs. And let's say frequencies are given like this. What we are going to do in this type of grouped data, this is called group data. In this type of group data, we'll be applying the formula. This is for individual data and this is for, let's say, grouped data, and specifically discrete series I am talking. This is a discrete series. Now this represent x, they represent f. So simply you multiply f with x and find out the summation. So what the formula comes? The formula comes sum of fx divided by sum of f. Obviously I stands for 1 and this is the always it will go like this. Look at the formula. You have to multiply the frequency with the x, like here I did it. You multiply this value, you multiply this value, and then you add all this value. It will come somewhere, it's 290. And you put it in the formula, 290 divided by, make sure that this denominator has to be the addition of frequency, addition of this column, second column. Second column stands for the frequency. This is 5, 6, 9, 10. So it comes 29. Simple formula of calculating arithmetic mean in the case of discrete series, and this is the formula for calculating arithmetic mean in the case of individual series. What happens when you get the data in the case, if the data is, let's say, maybe the data which is given in the form of values like marks and number of students, and the data is a big large, I mean it's not simple data, it can be in decimal, so you can calculate using the assumed mean method also. We'll take that. First look one more example based on the same concept. The marks of the student are given, the marks of the students are given, and number of students are there in front of it. Same concept, x is given. You can use a variable x, not necessary always go for x as we see. You can use a variable y, z, whatever is your choice. So whatever the variable which is representing the marks becomes your first column. The number of students which is there on the screen becomes your f. Fx you have to calculate. When you calculate fx, sum up the values, put it in the formula, you get the value of arithmetic mean. The numerical which is in front of you, you have calculated the x, given f, given calculated xf, multiplication f into x or x into f gives you the same value. So it doesn't matter. The sum of the fx comes 1490. 1490 is divided by the sum of frequency 35. Now it comes the answer, the value of it will give you the calculation 1490 divided by 35. It will provide you the arithmetic mean.